Hi, this is my fifth lab and I have taken the topic of escape velocity. I used the data that is given for my third lab to find the escape velocity. From the third lab I got the mass of the black hole. I calculated the mass of the black hole by using the Newton's second law and the universal gravitational equation F is equals to capital G m by r square. From that I calculated the mass of the black hole. The next thing I used, or the next principle that I used, is the energy principle. And from the energy principle I calculated the escape velocity. And the energy principle, the initial energy is equals to the final energy. So in this case the kinetic energy is half mv square and the potential energy is minus gmm by r. And the final energy, as you can see, is 0. As the object is moving away from the object which is attracting it, the kinetic energy is assumed to be as 0, or the potential energy, the distance is infinite, so it is also calculated, or it is assumed to be 0. So I equate, or when I calculate the escape velocity, I get the equation as square root of 2gm by r square. And I use the mass which I calculated by my Python code. As you can see, the Python code that I got here is from the same thing from the lab number 3. I calculated gave the mass of the star, the time, and the data that is given to me. The equations are pretty similar, I find, and the equation is stated as the rate of change of momentum is directly proportional to the force applied. And the equation that I inputted to find the escape velocity is this one. So from this I get the escape velocity as well as the mass of the black hole. And as I run the module, you can see the arrows representing different forces, the perpendicular force and the parallel force, as well as you can see the mass of the object and the escape velocity is being calculated. So if I stop as the program runs, as I will explain you about the other quantities. Again, the escape velocity of the earth is 11.4 km per second. That is calculated by the same equation by putting the value of mass of the earth in the place of the mass of the black hole that I have put here. So you can find the escape velocity of any object by finding the mass or the object which is attracting towards it, and using the mass of that object I can find the escape velocity. Again, here the escape velocity can be found, and I also give the equation to find the orbital velocity. The orbital velocity can be found by root of gm by r square. So the mass here is the mass of the object, the attracting object. For example, in the case of solar system, the sun is attracting all other object and the planets are moving around that one. So the mass that I have put is for the mass of the sun. And if I'm taking as earth and moon case, then mass of the earth should be inputted there. So this is the equation that I use and the energy principle. So as you can see, as my Python run and it stops here, you can see the arrows there and also the value that I calculated. See, you can see the mass of the object that I calculated here and the escape velocity that I got. This is 402.99 meters, and I changed that into kilometers, and the value is this one, as you can see, 56.27 km per second, and this is the escape velocity for my model. So thank you for watching my video.